In this video, we're going to take a look at quadratic functions, how to find the vertex, the x-intercepts, how to find how they intersect with other functions, and then we'll take a look at an application problem. So in this first example, we want to find the vertex, x-intercepts if any, and then sketch the parabola of f of x is equal to 8 plus 2x minus x squared. And just a reminder, the general form for a parabola is f of x is equal to ax squared plus bx plus c. So I wanted to write that just to make sure we use the right coefficients to find our vertex. Because remember, when we find the vertex, the x value of the vertex is equal to negative b over 2a. So when it's written out of order, you still need to make sure that you know that 8 is c, 2 is b, and negative 1 is a. So in our case, we have negative b, which is negative 2, divided by 2 times a, which is negative 1. So the x value of our vertex is negative 2 divided by negative 2, or 1. In order to find the value of y, we're going to plug 1 back into the original function. So I'm going to have f of 1 is equal to 8 plus 2 times 1 minus 1 squared, which gives us 8 plus 2, which is 10, minus 1, so we get 9. So the vertex is at 1, 9. And in order to find the x-intercepts, we're going to set our function equal to 0. So I have negative x squared plus 2x plus 8 is equal to 0. And now I think it's a little easier to find where this is equal to 0 if our x squared term is positive. So I'm going to multiply this entire function by negative 1. So I have x squared minus 2x minus 8 is equal to 0. And now it's easier to see that the factors are x minus 4 and x plus 2. So our function is equal to 0 at x is equal to 4 and x is equal to negative 2. So that means 4, 0 is a point on our graph, and negative 2, 0 is a point on our graph. So now let's graph it. We're going to graph the vertex and the two x-intercepts in order to draw this. So I have 1 and 9. So 1, 9 is a point on our graph, and negative 2, 0, and 4, 0. And now I'm going to draw the graph. So this is what our graph would look like for f of x is equal to 8 plus 2x minus x squared. The next example I want to look at, it says find the points of intersection of the function f of x is equal to x squared plus 3x minus 5, and g of x is equal to x minus 2. And remember, if we want to find points of intersection, we're going to set the two functions equal to each other. So I'm going to say x squared plus 3x minus 5 is equal to x minus 2. And now I'm going to move everything to the left side of the equal sign and set it equal to 0. So I have x squared, and then I subtract an x from both sides, leaves me with 2x, and add 2 to both sides, minus 3. And now we're going to write this in factors. So I have x plus 3 and x minus 1 is equal to 0. And then x is equal to negative 3 and x is equal to 1. So we have 2 points of intersection. In order to find the value of y for these x values, we're just going to plug it into either equation. So because g of x is linear and it's easier to use, I'm going to use g of negative 3. So I have negative 3 minus 2, or negative 5. And then I'm going to use g of 1, which is 1 minus 2, or negative 1. So our points of intersection are -3, -5, and 1, -1. And the last example is an application problem. So it says the daily profit from the sale of a product is given by P of x is equal to -0.01 x squared plus 16x minus 100, and it wants us to find what level of production maximizes profit and what is the maximum possible profit. So for part A, we need to find the x value of our vertex. So x is equal to -b, and in this case b is 16, so we have -16 divided by 2 times a, which is -0.1. And here we get 80 units. So it takes 80 units of sales for this company to maximize profit. And if we want to know what the maximum profit is, we're going to plug 80 back into our profit function. So we have P of 80 is equal to -0.1 times 80 squared plus 16 times 80 minus 100, and that is equal to $540. So the sale of 80 units will give the company a maximum profit of $540. And that's the video on quadratic functions.